Hi everyone, this is Nadeem Irshad, and today I'm going to talk on a very important topic. Every year, the South Asian monsoon crosses borders without passport, treaties, or permission. It forms over the Indian Ocean, builds across the subcontinent, and interacts with one of the largest river systems in the world, the Indus Basin. This basin stretches across mountains, glaciers, valleys, farmlands, and cities, connecting regions across both India and Pakistan through a continuous flow of water. And in that system, water does not stop at the borders. It moves according to the geography, elevation, and gravity. So when we talk about floods in Pakistan, we're not only talking about local rainfall, we're talking about a much larger hydrological system that spans across multiple countries and climates. In 2025, Pakistan experienced widespread flooding impacts across several regions, from the plains of Punjab to vulnerable mountain valleys. What made the situation complex was not just the local rainfall, it was the behavior of the entire river basin. During the monsoon season, heavy rainfall occurred across multiple parts of the region at the same time, including northern India and Pakistan. This influenced river volumes in shared basins such as the Sutlej, Ravi, and Chenab, which pass through or originate in upstream regions before entering Pakistan. At the same time, intense rainfall inside Pakistan added additional pressures on already full river channels. When rainfalls and river inflows align across a connected basin, water levels can rise quickly, and river systems begin to behave less like controlled channels and more like overflow networks. The impacts include large-scale displacement in flood-affected regions, pressure on flood protection and drainage systems, agricultural losses across key farming areas, disruptions of roads, bridges, and essential infrastructure. The key takeaway from 2025 was not a single cause. It was how interconnected river behaviors respond when multiple parts of the basin experience extreme conditions simultaneously. There are three major factors shaping modern monsoon and river behavior. First, atmospheric warming. Warm air holds more moisture, which changes how rainfall is distributed and how intense it becomes when it occurs. Second, Himalayan cryosphere changes. Glaciers and snowfields that feed the Indus Basin are evolving, which affects when and how water enters the river system. Third, rapid land use and urban expansion. Across both India and Pakistan, natural surfaces that once absorbed water have been replaced by urban infrastructure, reducing drainage capacity. Together, these factors do not act independently, they interact. And when they interact, they increase variability in how water moves through the system. To understand floods in Pakistan, you have to understand the structure of the Indus Basin. Major rivers such as Sutlej, Ravi, Chenab originate or pass through upstream regions before entering Pakistan. This means the basin functions as a continuous hydrological network. Rainfall in one of the systems can influence river conditions downstreams, depending on the timing, volume, and terrain. During monsoon periods, reservoirs and river channels in upstream areas can reach high capacity. When that happens, water management operations may include controlled release to maintain structural safety and prevent local overflow conditions. Those flows then continue downstreams through the shared river network. Historically, both countries maintain technical coordination mechanisms for sharing hydrological data, including river levels, rainfall observations, and flood-related information, under long-standing treaty frameworks. In recent years, experts have noted that coordination has become less consistent during some high-intensity weather events, with communication sometimes occurring through broader diplomatic channels rather than the continuous technical exchange. From a hydrological perspective, this matters for one key reason. Flood management depends heavily on timing and information flow. Because even small delays in understanding upstream conditions can influence how downstream regions prepare for incoming flood. Flooding in a system like the Indus Basin is not caused by a single factor. It emerges from a combination of conditions: rainfall distribution across multiple regions, river saturation levels, soil absorption capacity, timing of upstream and downstream inflows, infrastructure, and drainage capacity. When these factors align in certain ways, rivers move from stable flow conditions to overflow conditions. This is not unusual in natural systems. What has changed is the scale of exposure. More people, more infrastructure, more economic activity now exists in flood-prone zones. That is why modern flood impacts often appear more severe than in the past. Not necessarily because the system is new, but because the human footprint within it has expanded. The story of floods in Pakistan is not a standalone story, and it is not a story about one country or one event. It is the story of a shared river system shaped by geography, climate, and the time, connecting mountains, glaciers, reservoirs, and communities across South Asia. Understanding that system requires looking beyond borders and focusing on how the water actually moves through the landscape. At AI GeoNavigators, this is our focus: to study how environmental systems work and how they shape human life across regions. Because when we understand the system clearly, we understand the risk, the constraints, and the reality much better. And in a system as interconnected as this one, clarity is not just useful, it is essential.